Okay, Assalamualaikum semua. So for today we continue with evaluating the bivariate normality. Kalau semalam we use QQ plot and also the correlation coefficient to test for the normality of univariate variable, right? So today we see how to know whether the bivariate, okay, two variables are normal or not. Okay, same here. We can use two method, whether graphical or using testing. Alright, so we start. The first method here, mengikut slide yang ada. First method, we are using the test. Okay, using the Chisquare table. Alright. Okay. So dalam your textbook, this topic you can check in page 182. Okay, evaluating the bivariate normality. So here you can see, you can read dia punya step here. So I summarizkan. First of all, we need to check. Okay, we need to check whether the value of d square ataupun dipanggil square distance for every observation should be lie in the ellipse. 50% of the sample observation should lie in the ellipse. Macam mana kita nak tahu it should lies in the ellipse? Ellipse kan, we know that if the observation were generated from a multivariate normal distribution, each bivariate distribution would be normal, and the contour of constant density would be ellipse. So dia punya the square distance, okay, that you have learned before, this is the square distance, right? The square distance adalah the volume of the ellipse, right? Dalam ellipse tu, the square distance of ellipse. Okay, sorry, and the distance of ellipse. So we can check whether the observation that we have to lie in the ellipse or not. So how we can check the square distance here? The value of d square should be less than chi-square 20.5. If 50% or more of the observation lie in the ellipse, which is the d square less than the value of chi-square table, dia punya apa ni, degree of freedom is 2 and 0.5, then we can say that that observation lie in the ellipse. Okay, kenapa kat sini 2? Kenapa kita compare dengan chi-square 2 degree of freedom? Sebab kat sini 2 tu adalah P, right? Chi-square P. Okay, P adalah 2 here because of we deal with the bivariate. Okay, why 0.5? Because of we want to see the 50% of the sample. Okay, we want to check whether the 50% of the sample observation lie in the ellipse or not. So kat sini the value here yang kita kena compare whether it is lie in the ellipse or not for bivariate bivariate normality, we can compare with chi-square 2 0.5. Compare dengan d square. Okay, faham? Okay, in this example, we want to check whether the variables are bivariate normal or not, using the first method of testing, using the value of d square ataupun square distance. So we need to check the square distance for every observation. So untuk example 4.12, dia punya data actually this one. Okay, this one ada 2 variable. So actually this data is from the chapter 1 punya exercise. So we have x1 and x2 here. Alright, so we need to check for every observation. So here we have 1, 2, 3 until 10 sample size, right? And so we need to check this square 1, this square 2, this square 3 until this square 10. We need to check the square distance for every observation and check whether which observation that having the square distance less than chi-square 2 0.5. So kalau the square distance is less than the value of chi-square 2 0.5, we can say that observation lies in the ellipse. So kita nak check whether these two variable are bivariate normal or not. We can see whether 50% of the observation should be lies in ellipse. So maksudnya 50% of the observation should be less than the value of chi-square 2 0.5. Okay, so let's see here. So it's given x bar matrix of mean vector, dan diberi juga the variance covariance matrix, and then chi-square 2 0.5 adalah 1.39. So 1.39 ni you can find in the chi-square table. Kan tadi chi-square 0.5 here 0.5 here dia punya value of alpha, and degree of freedom is 2. So the value is 1.39. Alright, so untuk check for the bivariate normality, we always compare with 1.39 lah, because of p is 2 and 0.5 tu kita nak check whether 50% of the observation lies in the ellipse. Okay, so untuk nak check the d square, okay, d square we know that d square adalah ni tadi kan, x minus x bar transpose multiply inverse of variance covariance multiply x minus x bar. Okay, so here this part adalah x minus x bar transpose. Okay, x minus x bar transpose. So here x ada dua lah, because of we deal with two variable, x1 and x2. Kan tadi kita punya data ni, we have x1 and x2. So for every observation, the first row, this one dia the example for the first row. So kita masukkan kat sini x1 and x2 is 108.28 dan juga x2 is 17.05. Okay, so here is the first observation, x1 108.28 and x2 17.05. So we can replace here x1, x2, here x1, x2, d square for the first observation. So after we multiply all this matrix, so kat sini, let's say kat sini kan, actually ini adalah x minus x bar transpose. So kat sini dia punya dimension, matrix of dimension will be 1 by 2, right? 1 by 2, di sini 1 by 2, di sini 2 by 2, di sini 2 by 1. Last kali akan dapat 1 by 1, which is the value. Okay, 1.61. Nanti try lah. Okay, try akan dapat d square for the first observation adalah 1.61, which is more than the value of chi-square 2 0.5 tadi. So we can say that the first observation, x1 and x2 for the first observation tadi, pairing of x1 and x2 for the first observation lies in the ellipse. Lies outside the ellipse because of it's more than the value of 1.39. So ini untuk first observation. Untuk second observation, you check pula lah. Second observation x1 152.36, x2 16.59. Okay, you check, you masukkan kat sini, replace balik that two pair of the second observation tadi, last kali you akan dapat pula d square. So you see whether that value of d square is more than or less than 1.39. Kalau more than 1.39 means that that observation, the pairing of the observation tadi lies outside the ellipse. If the value of d square is less than 1.39, so we can say that that pairing of observation lies in the ellipse. So kena buat setiap satu ni. Okay, you need to replace all the observation, first observation until 10 observation in this d square formula, and you can see, and then you observe how many observation that having the value less than 1.39. Means that we want to know how many percent of the observation lies in the ellipse. If 50% or more lies in the ellipse, then we can say that the variables are okay, macam ni. If 50% of the sample observation lie in the ellipse, so we can say that the variables are bivariate normal. Means that the value of d square for each observation should be less than chi-square to 0.5. So we can say that the observation lies in the ellipse. Okay, so according to this example, if you can see on page 183, the first observation kat sini dia punya d square is 1.61, right? The second observation dia punya d square is 0.3, 0.62 until 1.16. If we can count here, only 4 of the observation having the value of d square less than 1.39 out of 10. Bukan, not 9 actually 10 observation, right? 10 observation altogether. So means that only 4 out of 10 of the observation lies in the ellipse. So means that only 40%, right? Only 40% lies in the ellipse. Observation lies in the ellipse. So we can say that bivariate normality is rejected. So we can say that the variables are not bivariate normal. Okay. Okay. So kita boleh juga tulis macam ni lah. Hash note dia, the variables are bivariate normal. H1 is the variables are not bivariate normal, and then we compare the value dengan chi-square to 0.5, which is 1.39. We will reject hash note. We will reject the hash note, which is the variable are bivariate normal, if greater than 50% of the d square is more than 1.39. Means that kalau d square more than 1.39, the observation lies outside the ellipse. Okay. Alright. Okay, another one method to see whether the variables are bivariate normal or not is using the graphical plot, which is chi-square plot. Okay, in your textbook, the step to construct the chi-square plot is on page 184. Okay, the first step is order the square distance from smallest to largest. Okay, so this one, order the square distance from smallest to largest. So the square distance adalah d square. Okay, d square. So now kita punya variable, we have two variable x1 and x2. So here, this part, so it will be like before this. You calculate the d square using the matrices. Alright, so we need to calculate the d square for every observation. Okay, for example, this is the example the data actually. Okay, d square. First, we need to arrange the d square from smallest to largest. Alright, so that is the first step. Calculate the d square and arrange from smallest to largest. We need the d square here to plot the chi-square plot. Chi-square plot actually adalah the y-axis is d square, x-axis adalah quantile. Okay, so once we have the value of d square, next step is we want to find the quantile. Okay, so before we find the quantile, first of all, we need to calculate the value of this one. Okay, this one, which is j minus half divided by n. Okay, actually that is the method, the same method when you want to find the quantile for QQ plot, right? So actually here before the middle here should be another column to calculate the j minus half divided by 10. This one, j minus half divided by 10. Okay, let's say we are using the same example from the previous topics. Okay, so j will be let's say for the first row, j will be 1. Okay, minus half divided by n will be 10. So the first row here, the value of j minus half divided by n will be 0.05. Okay, the second row will be 2 minus half divided by 10. So it will be 0.15. The third row will be 3 minus half divided by 10. So it will be 0.25 and so on. Okay, so we need to find that value to put here in here. Okay, put here because of we want to find the quantile using the chi-square table. Okay, using the chi-square table. Alright. Okay, so how to find the value of here using the chi-square table? Okay. Alright, so let's see the table. Oh, sorry, the table of chi-square. Where is the table? Okay, here, the table of chi-square. Let's say for the first row, here we want to find the quantile for the first row. It will be Q2 because of P is 2, right? 2 and the value of a probability is 0.05. So the value of probability will be 0.05. So it should be the value of 0.05. It should be at the here dekat atas ni value dia, kan? Alright, so macam mana you nak cari the value, the answer will be 0.1 tadi. The degree of freedom is 2. Okay, so the value of probability alpha berada di atas ni 0.05 yang kita nak cari tadi. Okay, so here data the distribution for chi-square here using this table, the value of alpha di sebelah sini. Okay, yang kita nak ni sebenarnya the value of alpha untuk chi-square plot ni adalah value here, yang kat tepi ni yang I buat ni. Okay, value here. So if we are using this table, we want to find the quantile for Q2 0.05 for the first row. 0.05, it will be 1 minus 0.05 lah, because of we want to use this table. Okay, okay, here 0.05 1 minus 0.05, so it will be 2 and 0.95. So dekat mana 0.95? So here. Because of that, the value is 0.1. Okay, the answer, the quantile will be 0.1 here. The second row pula, the value of probability tadi adalah 2 minus half. So kat sini should be 2 minus half divided by 10. So the value is 0.15. So using the chi-square table, the degree of freedom is 2, 0.15. So it will be 1 minus 0.15, which is 0.85. So it will be 2 here, 0.885 somewhere here, right? Somewhere here. So you need to do the interpolation. Okay, so sama jugalah. So last kali you akan dapat 0.33 dekat sini. Nanti cuba try buat. Okay, so same here until you get all the 10 quantile. So once we have these two column, d square and the quantile column, and then you just plot the graph as usual. Okay, so using this example, this is the chi-square plot that we will generate after using the value of d square and quantile tadi. Okay, so how to observe the chi-square plot? How to know whether the two variables are bivariate normal? Okay, actually it just like it's same as a QQ plot. Okay, we observe the plot whether it lies on the straight line or not. Okay, so for this example, we can say that the points are reasonably straight because of kenapa? Because of straight line here having the slope approximately 1 and passes through the origin. Okay, right? So because of that, we can say that the points are reasonably straight. So we can conclude that the two variables are bivariate normal. Okay, but actually because of our sample size tadi actually 10 saja, so the sample size is small, so it's actually it's a little bit difficult to reject the bivariate normal lah. So kita biasanya akan dapat result bivariate normal if the sample size is small. Okay, alright. Okay, so kat bawah ni another example here adalah example for when we know whether the four variate are normal or not. Four variate normality here. So actually this plot adalah example of chi-square plot for data on page 186, example 4.14. So here, if you can see on page 186, the table 4.3, the data for measurement of stiffness, we have x1, x2, x3 and x4. Okay, so first of all, macam biasalah, kita kena cari nilai d square for every observation. Contohnya kita punya data, okay, macam mana nak cari d square? So dia akan jadi macam ni lah, xy minus x bar, x2 minus x bar, x3 minus x bar, x4 minus x bar, kan? And then transpose here will be the value of variance covariance matrix dan juga x minus x bar. So x minus x bar transpose will be, the dimension will be 1 by 4. Dimension untuk variance covariance 4 by 4. okay, dimension for x minus x bar will be 4 by 4. Lastly, you will get one value. So we need to do the same for every observation. So you akan dapat the list of d square. When you have the d square, and then the next step is find the value of probability tadi lah. Okay, which is the j minus half divided by n. Alright, and then when we have the value of probability, so next step bolehlah cari nilai kuantal using the chi-square table. And then when we have the two column, d square and the quantile, so we can plot this plot. So apa yang dapat kat sini? We can say that the 4 variate is normal, are normal, right? Because of the straight line, we see the straight line, the slope of the slope, they're having the slope 1 kan, and passes through the origin. So we can say that these 4 variate are normal. Okay, so that's all.